In Chapter 15, we're going to discuss substitution reactions of aromatic compounds. Now, we saw in Chapter 14 a little brief preview of these types of reactions, and we're going to explore this in quite a bit of more detail throughout this particular chapter. So, let me show you what we're going to spend a lot of time talking about. If you think about the stability of aromatic compounds, we saw in Chapter 14 that they're very stable. And because of this, they're surrounded by high energy barriers with very large activation energies to actually get to different types of products. Now, the reason for this is if we take a look at a potential energy diagram, right? We know that aromatic compounds are relatively stable. So if I start at some hypothetical energy, I know I have an aromatic compound. I know it's a very stable structure. In order to have a reaction occur, to go to a non-aromatic compound, you see that there is a large difference in energy between an aromatic compound and a non-aromatic compound. And so the activation energy to get to the transition state, one, is going to be very high, and two, according to Hammond's postulate, is going to resemble that of the non-aromatic compound relative to the aromatic compound. Likewise, we see that in a potential energy diagram, if I start with a non-aromatic compound and I proceed to form an aromatic compound, again, the difference in energy is very great. It's relatively easy to form aromatic compounds, and the activation energy to get to the transition state, again, it's going to resemble the non-aromatic compound, and it's going to be very small. So these reactions happen very quickly, right? Whereas the reactions to produce non-aromatic compounds from aromatic compounds happen very slowly. In this chapter, we're going to essentially be kind of combining these two steps. And what we're going to see is that when you react an aromatic compound, we'll label it compound 1, what happens is, again, it goes to a non-aromatic intermediate, high activation energy, right? And then once that non-aromatic intermediate forms, right, then it rapidly proceeds to an aromatic compound, a new aromatic compound we label number 2, and we see that the transition state is lower than in energy than the first transition state, and so this reaction proceeds very quickly. So the energy barrier is to actually get to that non-aromatic intermediate and to get to the transition state number 1. The type of reactions that that aromatic compounds undergo that we're going to be focusing on in Chapter 15 are called substitution reactions, where we react an aromatic compound, here I have benzene, with an electrophile, which means that benzene is behaving as a nucleophile, and you get substitution reactions. So we start with aromatic compound 1, benzene, we end up with a substituted benzene, which would be aromatic compound 2. And we're going to look at the mechanism and the intermediates involved in this process.